Hello everyone. In this tutorial, we are going to provide a solution to this interesting system of equations. Square root of x plus y equal to 18 and square root of y plus x equal to 8. Let's get started. We can call this equation number 1 and call this equation number 2. So from equation number 1, I would like to make y the subject. So I can say that from equation number 1, we have y to be equal to 18 minus the square root of x, right? As this crosses over. And we can call this equation number 3, very important. Then we take this equation number 3 and plug it into equation number 2. Wherever we have y, we are going to replace it with 18 minus the square root of x. So you can see we have y here under the square root, so it becomes 18 minus the square root of x plus x. And this is equal to 8. Now let us take this x to the other side. We have square root of 18 minus square root of x to the left. And this is equal to 8 minus x. Next, let us square both sides in order to eliminate this outermost square root. If you square this, okay, let me do that. Square this, square this. This will cancel this, so we have 18 minus the square root of x. This is equal to, we have a binomial expansion here, right? First time squared, 8 squared is 64. 2 times this is 16, times this we have negative 16x. Negative x squared is positive x squared. Now let us take 18 to the other side, leaving negative square root of x equal to, as 18 crosses over, it becomes negative, so we have 64 minus 18, which is 46. 46 minus 16x plus x squared. I don't want to see square root. Let us square both sides again. You square this, you square that. This will cancel this. We have x to be equal to, wow, the expansion of this will give us an expression with degree 4 because we already have a degree 2 here. As you expand, you have to get a degree 4 and some larger numbers. Wow. Should I grab my calculator? Honestly, this is exactly how this equation should be solved. The only problem is, after expanding this, you may encounter some larger numbers which will eventually make the equation more complicated. But this strategy is absolutely correct. But let me show you a logic you can apply in solving the same problem. You can see that we have a square root of x here. We also have a square root of y. Definitely both x and y must be greater or equal to 0, right? And we have 18 and we have 8. So let us assume, because we have to make some restrictions here, let us assume both x and y are all perfect square numbers. Because if x is a perfect square number, you can easily take its square root. Yes, the same thing for y. So if square root of x plus an integer is 18, definitely the whole of this square root of x must be less than 18, right? So let us do a kind of substitution here. Let me use a be equal to this square root of x, which implies that a squared is equal to x, right? If you square both sides. And let b be equal to the square root of y, so that b squared is equal to y. So in the end, we are going to look for the values of a squared and b squared, right? So let us back substitute. You can see that square root of x will be a, so we have a here, plus y is what? B squared, and this is equal to 18. Do the same thing here. Square root of y is b plus x, which is a squared. And this is equal to 8. So look at it here. B squared must be a perfect squared, right? If it is a perfect squared plus another integer, we have 18. It implies that this perfect square number must be a perfect squared between 0 to 18, but it must be less than 18 because you have to add another number onto it to get to 18, which means that the whole of this b squared is less than 18. So if b squared is less than 18, we can say that b squared belongs to the set of values. Remember, it is a perfect square, right? All perfect square numbers from 0 to 18. We have 1, we have 4, we have 9, we have 16. So 16 is less than 18. If you take the next one, it will be 25. So let's stop here. These are the perfect square numbers between 0 to 18. Then if that is the case, what will be the value of b? b will belongs to the set of numbers from 1, 2, 3, and 4. You can do that by taking square root of these numbers. So we are done with b. Let us do the same thing for a. You can see that we have another perfect square number here, right? Plus another integer equal to 18, which implies that this perfect square number must be less than 8 because you have to add another number onto it to get to 8. So let me come here and continue. A squared must be a perfect square number from 0 down to 8. So we have 1, we have 2. Yeah, I think this is all right because 1 squared is 1, 2. Oh, 2 squared is 4, 3 squared is 9, but we have to stop here, 1 and 4, which implies that A must be what? Either 1 or 2. But we are going to relate. How can we relate? Let's start with the first equation here. If b squared is 1, then it implies that this value here, a, must be 17. And you can see that the moment you square 17, you get a number bigger than 8. So 1 will not work. Then let's move to the second one. If b squared is 4, if the whole of this b squared is 4, then this will be what? 14, right? And 14 squared is also greater than 8. If b squared is 9, 9 plus what will give us 18? 9 plus 9. Then a is also 9. Can you square 9 and add something to get 8? No. If b squared is 16, then 16 plus what will give us 18? 2. Yeah, you can square 2 and still add another number to get to, to get to 8. So I have gotten one combination. So I can see that b squared can be equal to 16 when a is equal to 2. And it can satisfy these two equations. Just observe. If b squared is 16, 16 plus 2 is 18. Take it down here. This is b, meaning you have to take square root of this before you get to b. Square root of 16 is 4. Then if you square this, you get 2 times 2, 4. It will give you 8. So this satisfies, but we have to test for this one as well. So if a squared is 1, then here, right? Then if this is 1, this is 7. If you square 7, you get 49. It will not work. If a squared is 4, then this will be 4. And if you square 4, you get 16. Yeah, definitely this combination will work. Then a squared is equal to 4 when b is equal to 4. But remember, this is what we are looking for, b squared and a squared, because we have declared a squared to be x and b squared to be y. Therefore, b squared is y, right? So let me start with a squared. Therefore, x is equal to 4 and y is equal to 16. These are the valid solutions for this system of equations. As simple as that. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.